In this session, we are going to discuss about the electrical safety. So these are the dangers signboard that you will come across if you're passing through the electrical lines. Now, how is an electrical shock received? When you touch the live conductors of two different potentials. Now, if you're touching the live conductors of two different potential, then we will be getting the electrical shock, because the current passes from the higher potential to the lower potential. Now, is it possible to get electric shock if you touch one live wire with your feet on the ground? That means is yes, right? Now, if you're touching our hand and one of the live conductor and then our feet on the ground, that means we are touching with two different potentials. Our hand in the live conductor, let's say higher potential, and then our feet on the lower, our feet, if it's on the ground, that means we consider the ground potential as a 0 volt. So which means there will be the passage of current through our body. During that time, you will get the electric shock. Now, is it possible to get electric shock if you are hanging from the live conductor? In that case, if you're maintaining the required distance from the ground, that means you will not get the electric shock, provided you should be maintaining the required distance from the ground. Now, there are also other factors which will affect the electric shock, like if we are wearing the wet clothing and then touching the live wire, then it's quite easy to get the electric shock. And then if you're in the humidity, high humidity, and then perspiration increases the chance of electrocution or getting the electric shock. Now these are the factors, which means like if you're talking about the wet clothing, high humidity, and perspiration, is talking about the liquid, right? Now if our body is wet, then there's a high chances of getting electric shock. Now we have to understand some of the terminologies for the electric shock. The damage caused by electricity to nature, okay, to the environment, to the properties. Okay, sometimes there the house burn or the building burn due to the electric shock, due to electric short circuits, and then there's also the damage caused to the life. Now, these are called the electric burn or electric shock, or sometimes we also call it as a electrocution. Now, the correct term to use is like if the death is caused by the electric shock, then we have to call it as a electrocution. And for the electric shock, we are receiving the electric current, but there's only the minor injuries. There's no threat to the life. During that time, we have to use the electric shock. And now to get the electric shock, the current passes through the body. It depends upon the resistance of the human body. Now, human body resistance is also dependent on the nature of the human body. Like if our body has a dry skin, then the resistance will be high. So there's less chance of getting the electric shock. But if our skins are wet and humid, that means our resistance value of the body becomes low and we have high chances in getting the electric shock. So here are the tragic case one. So actually this is the case study that I have prepared for the class, for the normal class, but since we are dealing it with online class, I'm just going to upload the slides in the Valley so you can have a read it yourself. Through these case studies, you will also understand why those men got the electric shock, or what could be the other steps to prevent that, those things. You will understand these things. Just you can go through by yourself. We're not going to discuss here. Now, the severity of the electrical shock depends on the amount or the magnitude of the current passing through our body. And then the second factor is the duration of the current passing through the body. The third factor is the path of the current passes through the body. Now, when you say about the amount or the magnitude of the electric current, I'll show you in the table in the later slides, because there are different magnitude of the current to cause the electric shock. Now about the duration, now even if the milliampere, 1 milliampere current is passing through our body for the longer duration, then there's chances of the electrocution, getting electrocution. And then the third one is the path of the current passes through the body, which means if that the current is passing through the heart, which is the heart, we consider it as the important body organ in our, like, important body organ. So if it's passing through the heart, then there's a high chances that you may get electrocution. So these are the three factors that the electric shock depends. First one is magnitude of the current. Second is the duration, the time period, and then the third one is the path. Okay, now here is the magnitude of the current for the electrocution. Now it starts from the 1 milliampere, and then it can go as much as like it can go as much as high, right? Like if 1 milliampere is passing through our body, then you can feel the electric shock, just a faint tingle, which means you can feel little bit. Then if it's again 5 milliampere, there's a slight shock felt, disturbing but not painful. So which means like these are not that much danger. 1 milliampere, okay, we are talking about the milliampere, okay, just remember we are using the word milliampere. So we're talking about the very minimum magnitude. And then again, now to cause the fatal death, like, we're not talking about the duration, no, just talking about the magnitude. Now to cause the electrocution is like 10 ampere, cardiac arrest and severe burn occur. Death is probable, which means 10 ampere or the 10,000 milliampere current is enough to cause the electrocution, which means we have to be very careful with the electricity. So we are just see it's 10 ampere or the 10,000 milliampere. We're just talking, this is the magnitude, we're not talking about the duration. Now if it's like we're talking about the longer duration, we may become ash. So we can go through this table and the description here. The types of the burn caused by the electricity: we have electrical burns, we have arc burns, we have thermal burns. Actually there are like a image for the electrical burns, arc burns and thermal burns, but these things are like I don't want to show it here. The reason behind this one is it's not looking good, like the image are quite dirty, so I don't want to show it here. Now, electrical burns, the burn that's a result of a person touching electrical wire or the electrical appliances. Now, which means if you're touching the live conductor, then you get the electric shock, and then that electric shock is causing some burns in our body parts. It's called electrical burns. Now, we also have another type of burns, which is called the arc burn. Now, arc burn is caused by arcing of high amperage current, which means okay, before that we should understand what's meant by arcing. Now if you try to bring, okay, let's talk about our domestic voltage, like it's 240 volt, negative and positive of 240 volts together, and if you want to if you try to bring it close, then after certain duration you'll find some arcing. Arcing is kind of like a lightning type. So the burn caused by that type of electricity is called the arc burn. And another example is we have the forest fire. The forest fire is also like a maximum case of the forest fire is a result of the arcing. And last one is we have thermal burns, which may occur if an explosion occurs when the electricity ignites an explosive metals, or in other words, it's thermal burn is also an indirect burn. Like you have through the electricity you have heated other appliances, and then if you touch that appliances, we get a burn. So we can also consider that one as a thermal burn. Thermal burn is the indirect burn from the electricity. Now we have understood about the terminologies like the what's meant by electric shock, what's meant by electrocution, and then also the level of the magnitude to cause the electric shock. Now, if you're getting the electric shock, what should we have to do as a to prevent this? And then here's a question: what should we do if your coworker is shocked or burned by an electricity? Now, these things, there's no exact answer for this one, but as per the standards, you may have to practice. First thing is, okay, let's forget about this slides. First thing is, you should be very careful while working with the electricity. Now, even if you happen to burn by the electricity, or your coworker or your friend is the victim, then you can follow the system. Now, this is what I feel. Do not touch the victim yourself if he or she is still in contact with the electrical circuit, which means if you're touching that one, you will also become one of the victim. So first step is, do not touch the victim yourself if he or she is still in contact with the electrical circuit. Then if possible, we have to switch off. Now in most of the case, if you're working in the buildings like the as an electrician, and if you happen to get the electric shock, then there will be the possibility of turning off the control gears like MCB, like switches, and then like you can also turn off the transformer switch. There's like a possibility. If it's possible, we have to look for that turning off for the or the deactivating the circuit. And then after that, we can also call for the emergency help like medical services. And if the victim is off circuit, now we have to check whether the victim is conscious or not. Now if conscious, okay, then we have to tell him not to move, because he will be out of energy. So we have to advise that, and you should let him to be in his own position. And then the fifth one is, quickly examine the victim for signs of major bleedings or burns. Now see, now if there's a major burns, then again, like we have already called the emergency. So we have to help with this in first aid. And if the third, again, the sixth condition is, if the victim is unconscious. If the victim is unconscious, then we have to check the sign of breathing, whether, now the unconscious means, it doesn't mean that he or she is dead, right? He or she is breathing, but just he doesn't have sense. So if the victim is unconscious, then we have to check the sign of breathing, whether he or she is breathing or not. If not, we have to help with the artificial breathing. Now we can just browse in the Google, or we can just do some literature how to do the artificial breathing. Okay, artificial breathing. So you can help him with the artificial breathing, and then finally we have to evacuate victim to the nearest hospital if possible. No, if possible, we have to evacuate him to the nearest hospital. These are the safety measures that I can advise, but at the same time, like this slides is also debatable. You may have your own PPE, the personal protection equipments. Like for example, if your friend gets electric shock, you may do other steps. Our ultimate aim is to save your friend or to save yourself from getting the electric shock. Okay, now this is how we should do with the artificial breathing. See, we have to give the breathing here, and then again we are doing here this kind of method. Now, these are the medical, actually the first aids you should also know as an electrical engineer. Now the next one is, the safety model. We have to understand the three stage of the safety model. Now in order to stay away from the electrical shock, we have to understand the three things. First one is, we have to recognize the hazards. hazard here, we have to understand that the threat or the danger caused by the electric shock. Recognize the electrical hazards, and then once you recognize that one, we have to evaluate how to where it is going on, from which part there's hazards coming on. Then after that, we have to try to control that hazards. Okay, the first one, the bullet points here are just an example. Inadequate wearing is dangerous. Exposed electrical parts are dangerous, which means there's no insulation in the electrical parts, which means it's dangerous, right? Then overhead power lines are dangerous. Now, these are examples. Now, you can uh, check in this way, like overload circuits are also dangerous. So you should not be doing that one. And then damaged power tools or equipments are electrical hazards. So you can just go through these points, and it's still the same one. And then now how to evaluate the hazards. After recognizing the hazards, now we should see okay, if you're looking into this one, if you're reading this one, an electrical tool, appliance, wear or connection that feels warm may indicate too much current in the circuit or equipment. So we are now analyzing that one, analyzing the electrical current. Why that electrical tool or appliance are getting warm? Which means when the electrical tools or the sockets or the extension cords are getting warm, something is wrong with that appliances, or there's short circuit in between. Now we should evaluate in this way, and then after that we should be dealing it with the controlling side. Like we should now prevent these things. We have to, for example, see, we have to treat all the conductors, even like a de-energized one, as if they are energized until they are locked out and tagged. For example, now if you're doing some maintenance in the substations, of course, so that the power supply for that substation will be turned off, but still then you have to de-energize those conductors. Then only you can start your work. And other things are like you have to lock out and take out circuits and machines, prevent overload wearing. And okay, now okay, let me give you the simple example. In our home, along with the switch box, we have the socket, which we also call it as a 6 ampere socket. Now that the maximum load that we can connect is 100 watt. Now from that socket, if you're connecting your rice cooker or curry cooker or refrigerator, that means we're overloading that one. That electrical socket will be not able to carry the load that you are connecting. So in this way, you should not be connecting this kind of load to that 6 ampere socket. We also call that 6 ampere socket as 5 ampere. Either it's 5 ampere or the 6 ampere socket. And then we also have other controlling techniques here, how to prevent exposure to live wires and parts by using insulation. See, now these are the preventive measures we're taking, or the precautions that we're giving. And then okay, the last one is to use the appropriate wear size. Now see, these are the wear size that you have to use. If our load is very small, we can use the small size of the conductor. If the load is heavy, then you can use the large size of the conductor. Now this is how you should be controlling the hazards. Now that's it about the electrical hazards. And the main aim of this presentation is something is talking about the safety, the electrical safety. Now electrical safety, as I said, it is not necessary that you should follow as per this presentation, but you can also have your own, but ultimate aim is to stay safe from the electrical hazard. Okay, that's it.